This is a part 1 that's talking about derivative of inverse function. Now, you learned from previous courses about inverse functions. Recall some of the information that we learned about it. Now, you know that for graphs, continuous and one-to-one functions f, then they have an inverse. The inverses is going to be, their graphs is going to be a reflection of each other in the line y is equal to x as it's shown in the figure below. If you focus on some points like p and f of p, you will find it's reflecting on the graph of f inverse is going to be f of p and p. Imagine there is a mirror on the line y is equal to x, where the graph of the function y is equal to f of x is going to be reflected on this mirror and give you the graph of y is equal to f inverse. Now, from this special relations between and the correspondence between the points in the two graphs, we could get to this relation, that is the domain of f actually is going to be the range of f inverse, and the domain of f inverse is going to be the range of f. What you could conclude from this picture, that is the function f inverse actually is going to be a continuous and increasing from seeing the graphs. These two properties actually carries from the function f itself. So if your function f is continuous and increasing function, then so is going to be your function f inverse. And the same thing if your function f is decreasing as well, then the f inverse is going to be decreasing as well. Now, if we are interested to know about the relation between the derivative of the two functions, then let us go back to the slopes of the tangent line. Now, you know that slopes of tangent line for increasing and differentiable functions have to be positive values. And also, the slopes of tangent lines for decreasing and differentiable functions have to be negative values. Now, theorem 3.7.3 says that suppose f is a differentiable function on an open interval a and b. Now, if either the derivative is going to be positive all the time on the interval, that means your function is increasing, or negative all the time on the interval, that means your function is going to be a decreasing function. Then the conclusion is that then f is going to be one-to-one function, that means the inverse function exists. Moreover, f inverse is going to be differentiable for all x in the range of f. This theorem is an existing theorem because it will tell you when you expect that to get your f inverse to exist. Well, as with any other theorems, you need to split your theorems into two parts, the hypothesis part and the conclusion part. Now, the hypothesis here is going to be the words written in the brown color. First, your function have to be a differentiable functions. Second, it have to be increasing or decreasing. That means the derivative have to be positive all the time in the interval or less than 0 in the whole interval. Now, what is the conclusion here? The conclusion here is going to be that your function f is going to be a one-to-one function. That means the inverse function exists. Secondly is that your inverse function is going to be differentiable on all points x in the range of f. Now, one of the questions that you expect to get in this section is the following. Prove that the function f, 10x cubed plus 8x plus 12, has an inverse. From its name, he just asks you here to prove that the inverse exists. Since asking about the existence of the inverse, then you're expecting that you are going to use theorem 3.7.3. But how are we going to do that? Well, let us try to answer the questions step by step. First, your function f is a polynomial function. So by that, you know it's going to be a continuous function and differentiable everywhere on the real line from minus infinity to infinity. Also, if you compute the derivative for this function, is going to be 30x squared plus 8, which is an expression is a positive one for all the values x. What does it mean? It means since the derivative is going to be positive for all real numbers, that is, your function is increasing on the whole real line. Then it follows from theorem 3.7.3 that f is 1 to 1 and the inverse function exists. Then you answer your question. In addition to that, your theorem will tell you that this inverse actually is going to be a differentiable function as well. So, once you are satisfying the hypothesis of the theorem, you are able to use it to conclude something about your function. This is what we have for this video. Now, please have a look at the other videos which is exploring more the ideas of the derivatives of the inverse function.